Thanks for watching my video. Today I'm going to discuss derivative of a function. So in order to find the derivative, so we used to start from that definition of derivative that is in terms of limit. Okay, so I'm going to show you, I'm going to discuss here about that. So let's say a function y is equal to f of x. Okay, now if this x value is changes, that means y value also will be changes. Okay, will change. That means y value depend upon the value of x. Okay, now we that if x value is changes, then y also will be changes compulsory. So and that changes, we used to say that changes, it may be increase, the change in value may be increase or decrease. Okay, that we call it increment, and that increment we denote by delta. Okay, we denote it by delta. So let delta y, delta y mean increment. Okay, increment mean increase or decrease value of y. That mean. So here y we have this one. Okay, so let's say y is increases to some value increment delta y. Okay, that means if y is so this also will be small changes will be there. Okay, delta x. Yeah, now delta y is equal to, if you transfer here, f of x plus delta x, if you transfer here minus, and y is what here, origin f of x. Okay, now let's divide both sides by delta y, not delta y, delta x. Okay, delta x means small changes or increase or decrease of small changes of x value. Okay, so let's divide it delta x. So here divided by delta x. Now if I take the limit, okay, limit where delta x tends to 0, so delta y by delta x, which is equal to limit delta x tends to 0, f of x plus delta x minus f of x over delta x. So we are going to discuss, I'm going to discuss in my other video about this one. Okay, limit. Now this one, limit delta x tends to 0 delta y by delta x. So this is rate of change of y with respect to x. Okay, so this we denote it by, in derivative we call it derivative, and this above, if this limit delta x tends to 0 delta y by delta x, if this exists. Okay, if this exists and is finite, mean example like 2, it is a finite, something like that. No, finite. If this is finite or exists, then we denote that this one by derivative with respect to what, downside here x. So we denote this by d by dx of what, y. Okay, d by dx of y, limit delta x tends to 0, f of x plus delta x minus f of x over delta x. One is y here, y, this one, derivative of a function. This one is in terms of limit delta x tends to 0, f of x plus delta x minus f of x divided by delta x. Derivative means small changes or increase or decrease of rate, or we say rate of change of something, this function. So This is the relation between no. This is the definition, okay, of derivative in terms of limit. So this one we are going to use in proving of derivative of sin x, cos x, tan x, and all this. We are going to use this formula.